Hello, everyone. Sorry I'm late. I was on a call. And I was like, I gotta go. None of this socializing stuff. This is crazy. All right, so humble apologies. Just had to get myself situated. All right, so what we're going to do, we're going to do like a quick review of what we were doing last time. So we want to figure out which point is the solution of our equation x plus 3y is equal to 6. And we have three sets of points. We have 1, 2, we have -2 and 8/3, and 0, 2. So what we're actually going to do before we get into relations and functions, we're going to substitute. So if you notice, when it comes down to order pairs, remember your x value comes first, then your y value. All right? So first is your x value, then your y value. So we're going to plug it into our equation. So instead of an x, I'm going to put a 1. Just going to put parentheses so you know I'm substituting. And then we're going to plug in a 2 for the y. And we want to see, is it going to give me my true statement, which is 6. So we have our 1 plus 3 times 2. So 3 times 2 gives me 6. And now we have 1 plus 6. That gives me 7. And last time I checked, 7 doesn't equal 6. So that means it is not a point. So I'm going to put a big capital U. Okay? So when you come across these, you definitely want to take a look. All you're doing is plugging in your 1 for the x, your 2 for the y's, and you want to see which one is going to give you what it equals. So 7 doesn't equal 6, boom, doesn't equal. Well, hello. I know. Thank you for sharing live. I greatly appreciate it. I am so sorry I'm a little bit late. I was on a call. All right. So now we're going to do the exact same thing. We are basically using, and if you're wondering what equation were we talking about, we're using this equation right here. Okay, that x plus 3y equals 6. So we're plugging in the -2 for the x. We have our plus sign. And we're going to plug in that 8/3 for the y. And we want to see, will it equal 6? Okay. Hey, Pops, how are you? So we have our 8/3. And you're like, oh goodness, there's a fraction. It's okay. All right. So if you haven't realized, it's going to be all right. So let me see if I can zoom in just a hair so we won't be like, I'm going blind. All right. So like an order of operations, we're going to be doing our multiplication first. So when I multiply a whole number with a fraction, we can actually have this be over 1. So if you happen to shoot in with us yesterday, we know that we can do what's called cross simplify. So we have this 3 and we have a 3. So 3 divided by 3 gives me 1. So if I want to, I can do this one of two ways. I can either multiply straight across, which will give me 24 over 3. And then I would divide. 24 divided by 3 will give me 8. Okay? You can do it that way, or you can do what's called cross simplify. So that means 3 divided by 3 will cancel out, give me 1. And what's left will be 8 over 1. And anytime you have a whole number over 1, it's just simply that whole number. So with that being said, hey, Memo, I'm back for more teaching. Welcome. Yeah, so you can definitely do what's called the reduction. So now from here, I'm going to bring down my equal 6, and I'm also going to bring down my plus sign and the -2. So now it doesn't look too hard, okay? It doesn't look too much of a really hard problem. Now we got -2 plus 8. So you have $8. You want to spend 2. That means you have $6. And since 6 does equal 6, that means that point -2 and 8/3 is one of the solutions to that equation. So I'm just going to write a big old yes. Okay. Hello, Holly. Teaching my friend Gabe Owner's abstract algebra. Okay. All right. Following. Thank you so much for following. Yes. All right. I see you. Hello, Tabitha. Thank you so much for the hearts. All right. So now that we have this, let's try for the next one. Let me slide over just a hair so we can kind of get everything situated. So now, again, we're using the equation, so that x plus 3y, and we're replacing the x with the 0, and then we're replacing the y with the 2. So in fact, it's going to look like this. 0 plus 3 times 2 equals 6. Okay, so based on what we did with the first one, after we substitute and solve, how many of you guys think that that 0.02 is going to be a solution to that equation, to that line? You can put yes or you can put a thumbs up. Either way it will work. Oh, and Sue's here. Hey, Sue. Oh, and King Cash is here. When'd you sneak in here? Lovely to see you, King Cash. And we have Ken's. Hello, Ken's. Dr. Brandon's popping in, popping out. All right. So we got a couple of yeses. All right. T. Lee, hello. Hi. Time zone difference. I know. Don't worry about being late. I was a little bit late myself, so no stress. I was on the call, and all of a sudden I looked up and I said, oh, it's 1:02. I got to go. All right. So we have our 0. We have our plus. 3 times 2 gives me 6. And 0 plus 6, that also gives me 6. So 6 does equal 6. So that works. Yes. So that is one of our solutions. So the only 2 points that works for that equation, let me see if I can shrink it back a little bit. So the only 2 points that actually work for those equation is my -2 and 8/3 and 0, 2. So for those that are just coming in, no stress. We're kind of reviewing a little bit what we did on Friday. So all we had to do anytime they give us an equation, they give us a series of points, you just plug it in. Plug it in to see which one will give you that 6, what will give you a true statement. All right. So that was a little synopsis, very, very slim, on what we were doing last week. That was a little synopsis, very, very slim, on what we were doing last week. That was a little synopsis, very, very slim, on what we were doing last week. That was a little synopsis, very, very slim, on what we were doing last week. So okay. Are we back? Let's see if we're definitely back. I love when people try to call me knowing I got work to do. I got people to educate. Talking about some foolishness. Yeah, so I'm not sure what you're trying to say. Can you integrate 1 over x raised to the third power plus 1? What do you mean? Okay, just put it in the chat so you can figure out what you mean. All right, so that's what we did last time. So what we're going to work on for today is we're going to look at relations Oops. All right, something's weird going on. Here we go. All right. Things are sliding over. Okay. All right. So relations and functions. So a relation is a set of order pairs. So order pairs is what I just have exuded here. So 1, 2, -2, 8/3, 0, 2. Those are order pairs because they're using your x and your y functions. Now, in order to get a relation, you just get a group of it. If I just grouped all 3 of these together, that's a relation. Now, but a function is where a relation, when no 2 order pairs have the same x values, aka they cannot repeat your x values. The y's can repeat over and over again, but your x's cannot repeat. So the best way that I think about this is, let me see if I can slide on down here. And the best way to bring it is, let me see if I can slide on down here. And the best way to bring it is, let me see if I can slide on down here. And the best way to bring it is, let me see if I can slide on down here. And the best way to bring it is, right? So you're born 10, you're born 6, 7, you're also 7. Now, think of it this way. Is it possible for 2 people to have the same birthday? Yes, because it's like right there. It's plenty for more than one person to have the same birthday. But is it possible for one person to have multiple birthdays? Now, don't give me that whole, oh, it's a leap year type of garbage, all right? Well, if it's a leap year, technically, Miss Audrey, all right, we're not talking about leap years, all right? But like, seriously, if someone was physically born, are they born on multiple days? Well, if they were born at midnight, obviously, if they were born at midnight, they're born the next day, okay? But can 2 people, can one person have 2 birthdays? Is that possible? How did this manage to show up like 30 minutes before I learn this exact information in my next class? I know, I'm psychological. Will this be on the test? Ken, so thank you, Kens. Like, no, one person can't have multiple birthdays, but multiple people can have the same birthday. So if you think of it this way, in order for it to be a function, your names, you can't have one person with multiple birthdays, but you can have multiple people with the same birthday, okay? So in order for it to be a function, your x's cannot repeat, okay? Your x's cannot repeat. Hey, Holly. All right? So when we're looking at a relation, it's basically the set of all order pairs as I mentioned. So your x's are the list of your x's. If I have more than one, that's your domain. Okay, a lot of people generally get domain and range mixed up. They just say, oh, my domain is my X. It's not just one singular X. It's the list of your X's. Your range is the list of your Y's. So if I take a look, I'm going to try to zoom in as best I can. I don't know. My zoom is just all kinds of cray-cray. There we go. All right, so we'll just work on one section at a time. So if I look at my order pairs, I have a -1 and 2, 0, 4, 1, 3, and -2 and 5. All right? So the first number in your parentheses is always your X values. Okay? The second number in your parentheses is your Y values. Think of the alphabet, X, Y, Z, right? So X comes before the Y's. So if I want to, I can also put it, and that's what I did with this chart, I put it almost like in descending order based off the X's. So I went from -2, -1, 0, and 1, and then I went with this corresponding Y's. So -2 had a 5, -1 had a 2, 0 had a 4, and 1 had a 3, just to mix it up, all right? So now, this is an order pair, this is a table, but then over here, with these two bubbles, this is called mapping. Okay? So, to the left of your mapping is your X values. To the right of your mapping is your Y values. So I try to keep it with the same theme. So -2 is my X value, and it should go to my 5, which it does. The -1 is my X value, and it should go to my 2, which it does. My 0 goes to my 4. Here's my 0, goes to my 4. Here's my 1, it should go to my 3. Here's my 1, and it goes to my 3. All right? So this is basically 1, 2, 3 ways to organize your relation. Okay? Are we good with relation? Greatness all. Hey, misbehaving. Nice to see you again. It's good to see everyone again. All right. So, taking a look at this. Now, I want to list out my domain. So all my X's, all of them are exactly the same, and so are my Y's. So if I want to list out my domain, I'm just basically listing out my X values. Now, some people would like to say if we want to list our set, because that's what it is, I say my domain, which is my D. Some people like to say, okay, my X such that. So X such that. So you're just emphasizing that my domains are the list of my X's. And all we're going to do is just list our X values. So it'll be -2, -1, 0, and 1. And then I close it. And you're probably like, ooh, how do you do those fancy little things? This is how I do my rule. I draw half a heart, okay, a little nose, and then a baby's butt. I know, but it works, right? So you're drawing half a heart, draw a nose, and a baby's butt. That's how I draw my little fancy brackets. Hey, Ray, how are you? Welcome aboard. All right. So for your domain, you're saying X such that, and then you list all your X values. For your range, guess what? That's my Y's. So that's Y such that, and then I list all my Y's. You can list your Y's in numerical order, okay, from least to greatest. That's perfectly fine because we already know what the pairs are. So if I start, I'm going to start with 2, then 3, then 4, then 5. Then a half a heart, a nose, and a baby's butt. Okay? This is what I need. All right, Juicy, I'm here. Just got up. Oh, I know. Washington. I know. All right. So this is basically what you need. So your relations is a set of all your ordered pairs. So your ordered pairs always comes with the X, then a Y. Then you can put it as a table. Your X goes to the left, then to your Y. Now, if you get one of those tables, I'm going to slide this over just a little bit past the mapping, I think. Okay. Sometimes people get the tables that's going to be more horizontal. Okay. Your X's are always on top. All right. So if you ever get some tables that look like this, so that means I have my -2, -1, 0, and 1. Then this was your 5, 2, 4, and 3. So sometimes the tables will be horizontal, okay? So if you ever get stuck and you're just like, okay, I see a table this way, but what happens if the table's this way? Then your X values will be on top. It will be on the top portion, all right? Okay? So today shouldn't be too stressful, okay? None of this should be too stressful. So now I want you to try, okay? So we got an example right down here. We have a set of ordered pairs, -4, 3, 2, 5, 1, 2, 4, -3. I want you to tell me what my domain is. So it's my X such that, I'll do that part. You just list them out. And then tell me what my Y is. So let's start with the domain. Once we all get the domains, then I'll tell you to do the range. So what's my domain of these ordered pairs? Actually, let me highlight it so you can see it a little better. Okay, there you go. So what's my domain? So I have Sue's got hers up there. All real from -4 to 4. So if it's all real, is 0 included in that? Do we have 0 included? Do we have -3? Do we have -2, -1? So we're actually going to list them out because not all reals are being listed. Okay? Artisan, fartisan. That's fun. Welcome in, everyone. Okay, anyone else want to try? Just listing your X values. Okay, Ray, we got -4. We got 4, 2, and 1. Okay, Sue had -4, 2, 1, and 4. NYX, do you want to try one more time? Because you're not too far away. We're not including all of those real numbers, just the ones that's being provided up here that's highlighted. What math is this? So this is Algebra 1. So we're working on our functions. And we're going to go a little bit deeper soon. So right now we're just working on relations and just organizing that. Okay. I was just guessing. I have a chem test to study for now. Thanks. Oh, okay, no problem. All right. So if we take a look, we're starting with the lowest one, which was a -4. Okay. If we want to do a numerical order, then 1 will be next, then 2, then our +4. Okay. So that is our domain. Those are our x values. What will be my range? Okay. Did I see Tink that just came through? And hey, Jeanette. So what would be my range? All right, Sue, look at you. She even put the brackets on. Hey, V. All right. So for V, it's going to be your Y values of the order pair. So we're actually going to list them out. Okay, Ray. Okay. So if we list out our Y values, remember, the first number is going to be our X, the second number will be our Y's. So if we want to put it in descending order, we could, which is a -3. Then we have a 2, then a 3, then a 5. Then I'm going to put my brackets with my heart, my nose, and my baby butt. Okay? All right. Hey, Bridget. Okay, when listed, should they be listed in numerical order or in order that the points are listed? I would say numerical order, because most books have it in numerical order. Okay. All right. And as long as you have those values. All right. So your domain is the list of your X's. The range is the list of your Y's. Copy that. Perfect. Now, I want you to take these same numbers and I want you to convert it into a mapping. Okay? So if we want, we can just go in order. So we have our -4, our 1, our 2, and our 4. Our Y's is going to be my range. And our Y's is a -3, 2, 3, and 5. But I want you to draw arrows to the proper order pairs. Okay? This is the original order pairs. So that means -4 should go to +3. So if I slide over, here's my -4, and I'm drawing an arrow to +3. Then 2 went to 5. So we draw an arrow. Then 1 went to 2. Drawing an arrow straight across. And then 4, +4, went to -3. Okay. So we got our relations together. Okay. We got them all matched up. hence the mapping. We have our domain, we have our range, and we're able to get our mapping. How are we doing so far? You can do thumbs up for doing okay, thumbs down if you're like, ugh, no. All right, Bridget, we're thumbs up. Okay, misbehaving. Are you about to fight me, misbehaving? Or is that just a fist bump? Sue, the thumbs up. Why are we fighting? Like, I feel like we're on Gladiator. No, seriously, are we fighting? Okay. I was like, ooh, we getting violent in these streets. All right. Oh, no, we're not doing that today. I don't know why everybody wants to, like, battle me. It's hilarious. Like, we're not battling. We're doing math. All right. Hey, Crystal, how are you? So that's what a relation is. It's basically a set of your ordered pairs all put together. You can arrange them as ordered pairs. You can arrange them as a table if you wanted to, and you can arrange it as mapping. So now we're going to take it a step further, and we're going to talk about a function. So remember what we talked about, the names and the birthdays. So we can't have two of your x values. Might have to unzoom a little bit. There we go. Or a lot. Okay. So with us, with function notation, trying to organize it in a way that's not all over the place. Okay, much better. All right, so when it comes to function notation, and this is probably something that a lot of you guys might see in your class with the whole f of x. Oh, thank you. All right, it might have that whole f of x type thing. So now this is what's happening. When things are a function, we're basically saying that we're following, the f is the name of the function. So the name of the function could be an f function. It could be a g function, an h function, an m function. It's just the name of the function. Just to give it a title. So the x is going to be your domain. Remember we talked about domain? So your domain is your input. And I think we did the whole plugging stuff in, just like how we did right from the very beginning. I'm going to flip over for a second. So just like what we did here, we input the 1 for the x and the 2 for the y. We're doing the same thing for the functions, okay? And what we get out as an answer, just like how we got 7 for an answer here, we got in the 6s for the answer here. What we get out for an answer, that's going to be this whole entire thing, the f of x. The f of x is your range. It's your output, okay? So the x is going to be what you plug in. The f is going to be what function we're going to use. But this whole thing, f of x, g of x, p of x, s of x, that's going to be your answer, your range. All right? So what we're actually going to do right now, we're going to do what's called evaluating functions. All right. So the only way that you can tell something is a function, there's two ways actually. If you look at it as a graph, oh, thank you for the gift. If you look at it as a graph, right, you can do what's called a vertical line test. So let me show you over here, and I'm going to put it underneath my steps part. I don't know, because I just feel like it. So let me see if I can smash that. So we got vertical line, and we're going to do a vertical line here. All right. So say that I have a graph. So say the shape of it is like a straight line. And I'm going to put that in a red. So the red line is my graph. When I do a vertical line test, that means it is a line that is going up and down, hence the name vertical, and it's going to cross my graph. If it crosses the graph more than once, then it's not a function. Okay? Right now, it's crossing this line's crossing the graph here, this line's crossing the graph there, it's crossing it here, it's crossing it once here, and it's crossing it once there. If it crosses it one time, it is a function. It's a go. It's a good thing. But if it crosses 2 times, let me do a rough sketch of a graph here. And let's say the graph is, let's see if it's like an ellipse. Okay. And I draw a vertical line through this graph. Okay, if I draw a vertical line through this graph a couple of times, now this is part of ellipse, all right? Noticing it's hitting here and here, just from that one line. It's hitting in 2 spots. It's hitting here and here. It's hitting at 2 spots. It's hitting here and here. That's hitting in 2 spots. Even if I draw a line here, and you're like, well, hey, Audrey, it only hits at 1 spot here. Still, but if I drew the line elsewhere, and if it just hits it at 1 spot like it did up here, then this is a function. Okay, so this is a function because it only crossed that graph, that red graph, at 1 spot per line. This one down here is not a function. Because it crosses our vertical line in 2 spots. Although it crossed at 1 spot here, but if I moved elsewhere on the graph, it only crosses, or it crosses at 2 spots. So that is not a function. Okay? So this is called using the vertical line test. All right. Are we okay? Are we still alive? Are we overwhelmed? Okay. Well, thank you for the follow. Appreciate it. We're still alive? Okay. Yes. All right. Bridget, yes. Okay. All right. I was like, I don't mind talking by myself, but I just want to make sure that you guys are overwhelmed. You're not overwhelmed. I don't want you to suffer in silence. No more suffering in silence. Okay? Yes. All right. Good. All right. So that's the difference between a function and not a function. And the other one is if your x's repeat. Remember the birthdays. One person can't have multiple birthdays. So that means that x value cannot repeat. If it does, it is not a function. But if it doesn't, it is a function. Okay, good. Not overwhelmed. Perfect. That's what I like to see. All right. So we're going to dig a little bit more into the function notation. All right. So that's how you can tell if it's a function. Your x values cannot repeat. Engrave that in your brain, all right? Now, with the function notation, let's see if I'm getting everything in here. Might have to zoom just a hair. All right, I'm gonna have to do it like this. It's getting kind of crazy with this book. All right. I know all this information. All right, so when we are evaluating a function, we're going to have some input. We're going to have some x values, okay? I will explain this at a later date, but that was really supposed to be for me. So I'm saying my x values, I'm going to substitute with a -2. I have a -1, 0, 1, and 2. Okay, so these are going to be my x values. I need to figure out what my y values or my range will be. And it's all going to be based from this equation. F of x equals x squared minus 3x plus 5. So wherever you see an x, all you're going to do is substitute the value of x. So I'm inputting, hence the word, I'm going to take this -2 and I'm going to input it into this function. So it's going to look like this. If I want to know what the f of -2 is, okay, because the -2 is the input, is the x. So I'm replacing the x with the -2. So now here, I'm going to have -2 squared minus 3 times -2 plus 5. Okay, so all I'm doing is substituting the -2's for the x's. Now this is the part, where were you last year when I needed you? I was here. I was here. I'm so sorry. All right. So this f of -2, this is what gets a lot of people. They're like, I don't know what to do with this thing right here. Guess what? This is just used to remind you that you plugged in -2 for the x's. You don't do anything with it until the very end. All right. So we're using this as a reminder to plug it in to that expression. So now let's break it down. -2 squared. -2 squared is the same as saying -2 times -2. What's a negative times a negative? Put it in the chat. Mine's yours. Yes. Good job. For Radiance, how are you? You snuck in here too. All right. Yes, yes. So negative times a negative gives me a positive. Good. And then 2 times 2 gives me 4. All right. So -2 squared, that's the same as saying -2 times -2. And a negative times a negative gives me a positive. 2 times 2 gives me 4. So now we have a -3. I know some people will say, well, that's a minus sign. The minus sign also acts as negatives, especially when there's multiplication that's going on right here. All right. So -3 times -2, what would that give me? Okay, a negative times a negative gives me what, V? Okay, Radiance, Jules, mine's yours. RMA, yes. Suze, yes. Okay, Arlie, yes. Okay, so that will give me a positive 6. Then you bring down the plus 5, that's on the end. We're okay? Good. All right, Melody. All right, so now from left to right, okay, let's combine. What's 4 plus 6? Okay, Radiance, I see what you're doing. So yes, so 4 plus 6, that gives us our 10. And then we add on the 5, which gives us our 15. So this is when I bring that f of -2 back down, because the f of -2 equals 15. So what this is saying, when my x value is -2, my y value or my output is going to be 15. You just found an order pair, guys. That's what you just did. Okay? You put the input into the function. You do your multiplication and combining like terms. The output or the answer that you get is going to be the y value of your order pair. All right? So let's do the rest. So now we have f of -1. Let me see if I change colors here. So raise up, come over here. So I'm going to see if I can put it right here. So we have the f of -1. Think you guys can see it? Okay, good. All right, equals. So that means this -1 inside this f of -1 is to remind you you're substituting -1s for the x's. So that means I'm putting a parenthesis, -1 squared minus 3 times -1 plus 5. All right. So -1 squared, that's the same as saying -1 times -1. What do I get from that? Good, Sue. Nice. Good. All right, so this gives me my 1. So now multiply -3 times -1. What would I get for that answer? Good. We got our 3's. Good. And since it's a +3, I'm going to put a +3. And then we bring down the +5. So from left to right, what will my result be? Okay. Ina, good. Radiance, good. Sue's map, good. Miss Libra, hey, Libras are here. Good. We're all going to get 9. So that means my f of -1 is equal to 9. So where I have my -1, we have our answer of 9. All right. So I'm going to set up the next one, but I want you to tell me what my output will be. So this time, oops, slight tilt, we have the f of 0. So what would my f of 0 equal? Okay, Miss Libra, double check. Because we're not multiplying 0 to everything. V Money. Welcome in, everyone. So I got a couple zeros and I have a couple of fives. Let's see if we can have a tiebreaker. Okay, Misbehave says it's 5. V Money says it's 5. All right. So let's see. 0 squared. 0 times 0 will give us our 0. 0, negative 3 times 0, that will give me 0. But then we have this plus 5. We're not multiplying this 5 to a 0. So we actually have 0 minus 0. Okay. Take nothing, take away nothing will give us nothing. But then plus 5 will give us our answer of 5. So that means the f of 0 is equal to 5. So for our table, where our zeros are x, 5 is going to be our y statement. Okay, let's try it again. Okay, questions with that one before we get to the next one. Okay, so 0 minus 0 gives me 0, and 0 plus 5 will give me 5. Okay, all right. So now let's try. We have our f of 1. So that means everywhere we see an x, we're going to put a 1. Let's see if you guys can see that. Okay, Melody is saying 3. Take your time with it. Okay. So remember, we're not doing anything with the f of 1 except for to remind us that we put the 1 in for the x. Hey, Cool Bean. See you trying to sneak in here. Hope you're having a good day. Okay, Sue's saying 3 as well. It's like, don't be afraid to put your answers up, guys. This is a safe space. We're just learning from each other. There is no test. There is no craziness. It's perfectly fine. Okay, we try to make this as fun as possible. Okay, persistent trader. All right, so you have 7. Okay. You know, we're just going to learn from each other and just be able to figure things out, okay? This is not Squid Games. I'm not going to off you. No, we're not doing any of that, okay? So I have 2, 2, okay. And then we have another person with 3. All right. Lakota Chica. I want to say Lakota Chica. I love your names, guys. Very inventive. All right. So since I have to get going at 2, that's the only thing about this 1 o'clock slot. I have tutoring. But we have 1 squared. So 1 squared is the same as saying 1 times 1. And 1 times 1 gives me 1. Then we have negative 3 times 1. So negative 3 times 1, when you have a negative times a positive, your answer is going to be negative when the signs are different. Then 3 times 1 gives me 3. Then I bring down the plus 5. All right, So now, this is the part that everyone gets a little weirded about. We have to go from left to right. You can't go from right to left. Okay, it's always from left to right. So when I combine 1 minus 3, so I have $1 and I want to buy something that costs $3, that means I am $2 short. Bring down my plus 5. Then negative 2 plus 5. So I have $5 and I want to spend $2. So I got $3 left. Okay, do we see that? All right, so the answer is going to be 3. So that means the f of 1 is equal to 3. So when we go to our table, where the 1 is, we're plugging in 3. Okay, all right, you got it? Good. I went the other way. Yes. And trust me, a lot of people generally do. Because we're so torn, like we're so trained to go from your highest number down. That's not the case. You always go from left to right. Okay? So, let's redeem ourselves. So we got one more. So, oops. This time we got the f of 2. We got this. Take our time with it. So we have the f of 2. So wherever I see an x, I'm going to put a 2. And let's see if you guys can see that. I would love to lower it so you can see the first one that we did, but I'm not sure if the numbers are in the way. Okay, so use this first one up here as a guide. Okay, use this first one as a guide. Okay, thanks for sharing the live. Let's see if this person's still here. Okay, we got 3, we got 3, we got 3. And just because other people have 3s, don't go changing your answers. I know that trick so well. Oh, they got 3? Oh yeah, I got 3. Okay, Taylor the creator, good job. Hello, welcome in. Okay, so persistent Taylor, we got -3. All right. Oh, thank you, Melanie. I really appreciate that. All right. Hello, Jennifer. All right, so let's take a look. Let's see. V, I'm kind of waiting for you, V Money. Let's see what you get. She's like, damn. It's just like in class, like, don't call me out. Please don't call me. You know, so every time when you see the teacher walks around with the popsicle sticks that used to have the names on it, as soon as you see her grab that thing, everybody's like, what? Why? Just ask James. He knows everything. All right. So let's see, because I do have to get to my person. All right. So 2 squared, that's the same as 2 times 2. And what's 2 times 2, guys? Misbehave knows. All right. 3, easy. All right. So we got our 4s. So now we have 3 times 2, which gives me a negative 6. Then I bring down my plus 5. All right. So now, going from left to right, we have 4 minus 6. What's 4 minus 6? Okay, negative 2. Good. All right. So if I have $4 and something costs $6, that means I'm $2 short. So now I have 2, right? So negative 2 plus 5. Okay, so if I have $5 and I bought something for $2, that means, yes, thank you, user, all that. I know, it's hard to find usernames. So that'll give me my answer of 3. There you go. All right, so that means the f of 2 is equal to 3. So when the 2 was the input, the 3 was the output. All right, so since my x's did not repeat, that means we do have a function, okay? And we found our domain in this function. And we notice that right here at the bottom, these last two gave us the same range, and that's perfectly fine. So if I wanted to kind of write out, because we already knew what the domain was, if I wanted to write out what the range was, we have our y such that, and we can start with the bottom numbers or put it in numerical order. So you have your 3, you have your 5, your 9, and your 15. But you're probably saying, hey, Audrey, you didn't write the 3 down twice. Now, when you're writing the set, you don't have to write it. If it repeats, you don't have to write it twice. You just have to write it once. Aren't we solving for f? We're not solving for f. So all we're doing is using function notation to find our result, to find our y values. The f is just tells us which function to use. So like if I had more functions, like if I had an f of x, a g of x, and an h of x, it will tell you which function we're actually going to use. All right, so I have to get going, but this was good. We're going to do more of this tomorrow, okay? So I'm going to add this for another day so we can do it with multiple functions at the same time, all right? So thank you. Do you go live at certain times? Yes. So at 1 o'clock, Monday through Friday. And I'm also on at 8:30 Monday through Thursday, p.m. Eastern Standard Time for those. Oh, thank you. I appreciate that. Yeah, so cool bean. Yeah, I'll try to come on time tomorrow. Not a problem. No stress. I'm going to be here. If not, you got me another day. Okay. All right. So not a problem. I will see you guys tomorrow or maybe even later on. Later on, we're going to work on factoring. So usually I do like certain steps in the morning and then certain things in the afternoon so people won't get bored with me doing the same things both times. All right. So if you ever need me, have like a question of anything, just reach out and let me know. All right, guys, have a wonderful day and I'll see you either tonight or tomorrow. All right. Bye.